Now you guys have seen these problems before. We're given an equation and we're asked to find the slope, or we're asked to find the y-intercept, or we're asked to find the x-intercept. So I just want to remind us how to do that. So most of us know y equals mx plus b. This is our y-intercept. This point here is our slope. What you might forget is that the x-intercept is when y equals 0. So if we're given an equation like this and we don't really see the y equals mx plus b, what we're going to have to do is we're going to have to manipulate that around so that we solve the equation for y. So in this case, I would do that by dividing everything by 9. So I get a y equals on this side, I get a 3/9 or 1/3 x, and a -9 divided by 9 would be a +1. Okay. Now again, that's still not in the exact form that we're used to seeing, but you should recognize a couple things. One, the slope is the coefficient in front of the x, so the slope would be 1/3. The y-intercept we recognize is when x equals 0. So if x is equal to 0, y will equal a 1. And then what I saw the other day was a lot of us didn't know that the x-intercept is when y equals 0. So if you substitute in y equal to 0 and solve for x, that's how you get the x-intercept. So if I do that on this example, I would get 1/3 x equals a -1. Multiply both sides by 3. I would get x would equal -3 is where this line crosses the x-axis. On your practice test, you've seen some questions about sequences. And basically on the ACT, there's two types of sequences. One is an arithmetic sequence, which goes up or down by the same amount, and that's called a difference. So you look at your two terms, and is there a way that I can get from 2 to 22? The answer is yes, add 20. If you can keep adding 20 and get the next term, that's called an arithmetic sequence. And basically on the ACT, sometimes they'll just ask you for the next couple terms. So just continue that pattern. If they ask you what is the common difference, the common difference is what they differ by. And again, this can be a sequence that goes up, or it can actually be a sequence that goes down. So if I went from 1 to -4, I'd go down by 5. And my common difference would equal a -5. Okay. There's two common sequences on the ACT, arithmetic and what we call geometric sequences. And geometric sequences will have a pattern, but instead of going adding and subtracting, these will multiply to get to the next number. So we'll look to see if there is a pattern that we can see. Is there a number that if I multiply it by 3, I'll get 18? Some of us will see that that's 6. If I multiply 18 by 6, I'll get 108. By 6, I'll get 648. So yes, this is a geometric sequence, and if they ask us for the next couple terms, just keep multiplying by 6. The last two sample problems for this lesson are just a reminder about how we solve and factor. Remember, solving is finding an answer such that x will equal 0. And if we don't have 3 terms, remember we look to see if there's anything common. And we factor that out. We set each one of these values equal to 0. And we have 2 answers. Again, on the ACT, if there's any time to go back and check your answers, that's always a good strategy. The last example that I included in this lesson is one that looks like a factor problem, but what you have to remember about factoring is that this right-hand side has to equal 0. So if it doesn't equal 0, we have to, in this case, we're going to add 6 to both sides so it does equal 0 before we factor. That's usually a trick in there, so I wanted to include one of those today. Factoring, what are the factors of 12 that add up to 8? The factors of 12 that add up to 8 are a 6 and a 2. But remember, when we want to solve, that means we want to find answers. So we set each one of these equal to 0, and we get our two answers as a -6 and a -2. Now you're ready to finish up Skills 6. Check your answers and make sure you record those in the folder.